So we work in a field called DNA nanotechnology. What we do is we remove DNA from its biological context, which is what most of us know it as the programmer of life. And we use it to build very, very small machines and nanoscale objects at small scales. We use it as kind of a construction motif, the same way that you use Lego to build things. We use DNA to build structures, but just in very, very small scales. So some of the things that we've made in the lab include little bricks that we can assemble together into one-dimensional polymers, as well as multi-dimensional materials. And we can also design things like flat sheets or specific structures. We're aiming to achieve the control of motion at the nanoscale. In the macro scale, we're very easy. We can move our limbs, we can move things around, we can transpose things with relative ease. But at really small scales, we don't really have the tools yet that we can control where things go and how fast they move. If we want to start designing robots at very, very small scales, we need to be able to transpose those abilities to move into a smaller scale. The dream is to make a robot that looks like what we see in the macroscopic world at the nanoscale. So at these very small scales that are smaller than the width of a human hair, how can we get a little robot to manufacture different chemicals? How can we get it to move autonomously? And how can we get it to replicate itself? So one of the impacts that I think would really come from this is in the delivery field, where we're able to control the release of medicines over specific time periods using our techniques that we're developing in the lab. But I think that for now, at least, the impact is definitely on the horizon, and we're focused on really the fundamentals of the chemistry surrounding these materials. I was very shocked and incredibly humbled by receiving this award. It was actually amazing to get that phone call. So much in academia, you're kind of, working with colleagues, working in a very confined space, let's say, but to have this be so embraced by the scientific community as well as the government and industry participants on such a wide scale is actually really mind-blowing. It's truly exciting. I'm also incredibly privileged to work with, young people who really drive and inspire me every day. In particular, my HDR students and PhD students. Cannot thank them enough for how inspiring they are, how devoted they are, and how inventive they have been for our chemistry moving forwards.